So to help us go back a bit in time, we're joined by Jack Heslewood. Now, Jack is a rocket scientist who has worked on so many aerospace projects since he graduated from Kingston University in 2012. And he's also, would you believe, the current Mr. World, which is amazing. Woo! And that's the largest male pageant in the world, where he had to compete in charity fundraising, sport, fitness, modelling and talent. So welcome, Jack. Thank you for coming in.
Thank you guys for having me. It's a pleasure.
Excellent. Well, you know, one of the things we've got to ask you is, we want to know, everybody will be asking now, you're Mr. World.
That's right.
How on earth did that come about?
So this is a way of, so basically it's a beauty pageant, but what they do is they look for people who are very well-rounded. So I'm very big on science. I love science. I play drums. I'm a big musician. I love sports. So it was a way of a competition where you do so many different things and they judge you based on those things. So I am the first British person to win the competition since it was founded. So it's coming home. And so that's really, and what the Mr. World, what it actually means to be Mr. World is that I can spread the word of science to pretty much people all over the world.
Fantastic, and brilliant. We could have you in here today then.
Yeah, it's a
Fantastic.
pleasure.
So you just said that you were big on like music and drums, and it's interesting, isn't it? A lot of people who are engineers, mathematicians, scientists, seem to be very good at music as well. Is there something that correlates between those things?
Well, there is a lot of theory that goes into music, and there is a lot of mathematics that is at play. When you hear something that sounds good, it's actually, there is a mathematical way of explaining how or why it sounds good to your ear. And there's, with drums, it's a lot about rhythm. So it's, you need to keep time. There are bars and there's structure in music. So it could be as technical or as creative as you like, so that's why it's such a popular thing. But
brilliant. Now you're into space in a big way, aren't you? You love everything to do with space. So let's start with, for our viewers at home, really, where does space start and where does sort of the atmosphere finish? Because there's all sorts of discussions about that. But where's the kind of line drawn?
Absolutely. Well, you say I'm into space, but Mark, what would you say if I was to say that we are actually in space right now? So the only real difference between, as we're sat here now, able to breathe and outer space, is our atmosphere. So that is the only thing that actually separates us from outer space. And the atmosphere really doesn't have a definite edge. So it just gets progressively thinner the higher up you go. And NASA have defined this as 100 kilometers, which is 60 or 62 miles. So as soon as you get to that point, NASA have said, that's outer space. There's not enough air to breathe. You're in a vacuum. We can send satellites to orbit around the planet, around the Earth, and send them into space. And it's actually shown on this picture here, which was exceeded just, I think it was this week, wasn't it, that Blue Origin actually exceeded that by 5 kilometers. So they went higher than that line, vertically upwards. And then previously, Richard Branson in Virgin Galactic did the same. He didn't quite reach that 100 kilometers, but that's what I want to talk to you now about, because it really depends on what you're trying to achieve in space. Because if you are trying to purely just get into space, you would feel very much like you are in space way before that 100 kilometer Kármán line, it's called. So there are different reasons, and I want to get into those different reasons a little bit more detail in a second.
Brilliant. So before we go into that, there's loads and loads and loads of different types of rockets. We've seen Richard Branson's, which is more of a kind of little plane. We've seen rockets that are like Elon Musk's one, and then there's the NASA ones going back sort of over the years. How many types of spacecraft and different things, things that orbit are up there then?
So there are many. There are actually over 250 different robotic spacecraft operating in space as we speak in history. So they can be a number of things. They can be a rover, which is designed to actually, it's like a car that drives on the surface of a solid planet like Mars, the Mars rover. Or there can be probes that are sent out into vast space to go and they do flybys of different planets. They measure radiation, gravitational waves. They measure these big, they're called coronal mass ejections. These big, trying to describe it, it's like almost like a firestorm that comes off of the surface of the sun. And so they can measure the density of those, and it gives us a lot of interesting information about how the universe was formed. There are landers which purely would land on an asteroid. I think there's actually a picture of the European Space Agency's lander, and it landed on an asteroid.
Wow.
So you have Mars. You have the Mars rover, for example.
That's a lot of stuff up there. I mean, so if we're putting all these things up there and all the satellites and everything else, I mean, eventually will it all come down? I mean, how do we get it all back down to Earth?
So we do have that problem. So we have satellites that have been up into space for many years, and they're orbiting our planet. And some of them have been, finished their mission. They need to come back down now. But we need to. It's one of the challenges for our current generation and the next generation that are watching, is to figure out ways that we can bring these back. So one of the convenient ways with satellites is that if you bring them back into the atmosphere, they're traveling at such a high speed that they will actually break apart. There'll be so much air friction because they hit the atmosphere. So they'll be orbiting Earth. There'll be barely any air there. They can just move freely. They're traveling over 20,000 miles per hour.
Wow.
So as soon, if you were to bring them back into the atmosphere, they would burn up, and they would be burnt up way before they hit the ground. But we also have other issues around that really need to be addressed, because it's not always as convenient just to burn them up in our atmosphere.
Wow. And you studied to become a rocket engineer, didn't you? Is that right?
An aerospace engineer.
An aerospace engineer. And is rocket engineering your favourite area of that? Or what sort of area of aerospace engineering are you into?
Well, I'm interested in in everything to do with space, but I really like the design of rocket propulsion. Right. So I like actually designing the rocket engines, and it involves lots of different elements of science. But it's also the other areas, like it's not just aerospace engineers that work in the aerospace industry. You have astrobiologists. What they do is they will look at different samples of rock that have been drilled and collected on the surface of Mars or the Moon. Wow. They will be able to see if it's possible to live on Mars. And we've actually seen that from a few space missions recently that it was possible in the past that Mars actually was a habitable planet for a species like ours that needed water. So that's really my main focus, is the propulsion side. That's my favorite part.
And some of us, and a lot of the viewers at home, might not be massively interested in science, but could still love space. So is there a way you can still work in aerospace but not necessarily be a scientist?
Yes. Wow. So you don't need to be a rocket scientist necessarily to work in space. So, we always need to recruit people to come and work in space. We need to market it and spread the word of what's happening in space, and we need to try and get people to support it, wealthy investors and governments to support it. So there are still other things that you can do in the space industry if you love it that much that you want to work in it, but aren't necessarily, or your maths and science aren't your strongest subjects at school.